Hello student, today is our second session online and this is your textbook, Calculus with Applications. The section I'm going to discuss today is 6.4, Implicit Differentiation. Let's define what is implicit, what does it mean by implicit, and what is explicit. If we can separate x from y when y is a function of x, when we can separate independent variable from the dependent variable. Here x is independent variable, y is called dependent variable. Y depends on x. So when we have a function like y is equal to f of x, and if we do any differentiation, since these are separate from each other, therefore what we do is called the y is given explicitly in terms of x. That's explicitly. So here we have explicit. But if we cannot separate from each other, in other words, when we have a function like f of x and y is equal to something or equal to 0, in other words, x and y are together, and therefore we are looking for the derivative. Again, these are implicit. X and y are implicit with each other. Y is implicitly is in terms of x. Example, I can give it to you. For instance, if y is equal to x squared plus x minus 1, for the first one, you can take the derivative, find y prime. But here I can give you the example like from the book, for instance, 3xy plus 4y squared is equal to 10. As you see it, x and y are together and you cannot separate them. You cannot solve these for y. And in sometimes also it's even harder than this. If this is more than 2, like 3, 4, 5, then it would be even a little more complicated to solve it and change your implicit form into the explicit form. So in other words, this is what we are using to find y prime. It's called implicit differentiation. So implicit versus explicit. Now I can give this example and use implicit differentiation to find the derivative. So the example 1, page 350 of 6.4, which is called implicit differentiation. And in this case, then we have to take the derivative of each term of above equation. 3xy plus 4y squared is equal to 10. Because we cannot separate y from x, because we cannot solve for y, therefore we have to take the derivative of each term with respect to x. This one, and this one with respect to x. So separately, like here, what's the derivative of xy, for instance? 3 is there, then you can multiply, or 3xy. The derivative with respect to x, you can write it this way, d over dx of 3xy, and then you can separate this like u and v. You say this is u, this is v. You use product rule, u prime v, v prime u. So you are using the formula u prime times v plus v prime times u, and you assume this is u and this is v. So the derivative of u would be u prime, which is t, 3 times y, plus the derivative of y with respect to x would be y prime times 3. And then you will go to the second one, which is 4y squared. Take the derivative with respect to x. Here you have to use the quotient, the chain rule, which we had like for u to the n. And the derivative of u to the n was n times u to the n minus 1 times the derivative of u with respect to x, which was u prime. That's called the chain rule. If you remember, this is the chain rule formula. So here, instead of u to the n, you have y to the n, or here y squared. Therefore, the derivative of this becomes 4 times y, u to the n is this formula, so y squared would be 2 times, 2 comes here, n comes in front of y to the 2 minus 1 times the derivative of y with respect to x. That was because of the chain rule. Remember the chain rule? We should take the derivative like the power rule, but in the end you gotta multiply by y prime or u prime. So this is what we have. This actually is 8y y prime. Therefore now you have the derivative of this first term, derivative of the second term on the left side, and derivative of 10. Everybody knows what's the derivative of 10 with respect to x. The derivative of the constant is always equal to 0. So we take this and substitute, plug in the original equation. When you plug in the original equation, this is what you are getting actually. So you will get 3x plus 3y prime, 3x plus 3y prime. That's instead of the first one. That's the first one. Plus derivative of 4y squared, which was 8y y prime. That's the second one. Y prime, when we say y prime is nothing but dy over dx. Remember, what's a y prime? So y prime is dy over dx. Then what is the right side? 10. Derivative of 10 is equal to 0. So this is what we have actually. So from the original equation, using implicit differentiation, this is what you get. So what is the question? Question is, can you find y prime? Yes. First term has a y prime, second term has a y prime, third term is a y prime. First term, move it to the right because it doesn't have a y prime. Therefore what you have is 3y prime plus 8y prime is equal to minus 3x. And then take the y prime as a common factor out. So that will give you y prime times 3 plus 8y is equal to minus 3x. Now if you get rid of these, the factor of 3 plus 8y by dividing both sides, 3 plus 8y, then what you are getting is actually your y prime, because these two will be cancelled. Therefore, as a result of this division and this factoring, and the fraction that you are getting is your final answer, 3x over 8 plus 3y. This is called first derivative of, which comes from here, first derivative of y with respect to x is y prime or f prime of x. Sometimes they may write it down this way. And we use it for the slope generator. If you have x and y, you plug in here x and y. Therefore, this will give you a point, a number, which is the slope of a slope function. Then we could find the equation of tangent line. So let's do another example, this time maybe to go a little bit further than that and discuss about the tangent line, maybe one problem from tangent line. And this time what we have is the graph of, that's example 3 again. Example 2 is good also, but example 3 is in application. At least they talk about the equation of tangent line. So what I have is x cubed plus y cubed is equal to 9xy. Question. That's the question actually. Can you find the equation of tangent line at the point 2, 4? And of course, if this one, if you build your calculator, if you find the picture of that, and picture something looks like this. The point that they give you actually, one of the point actually is here, that they're asking you, can you find the equation of tangent line? 1 point, they give you 1 point. Can you find the equation of this line to this curve? This is the curve y, whatever the y is. Y is f of x. And then Folium, that's the name. Folium, Descartes folium, they have this curve, and they have this equation. René Descartes, the French mathematician, he already found this and worked on it. We have to take the first derivative, implicit differentiation, and then substitute the point. The point they give you already. The point is, I think it was 2, 4. That's the point is at 0.24. That means x is 2 and y is 4. So first, we got to find the first derivative. Is like what we did in the previous example, that we got this y prime equals to a fraction minus 3x over 8 plus 3y. Something similar, we can find it here. We have 3 terms. 2 terms on the left, 1 term on the right. So how do we get the derivative of this? Using implicit differentiation. Implicit differentiation means you take the derivative of each term, because x and y, they are not separate. So we cannot do explicit differentiation. We use implicit differentiation. Everybody knows, then I don't have to do here separately, one by one. First term, derivative of x cubed with respect to x would be 3x squared. Derivative of y cubed is like y to the n, is like y squared that we did before. Using the chain rule would be 3y squared times the derivative of y, which is y prime. And then 9xy on the right side. Is like here we have 3xy, here we have 9xy. So you take 9x as a u and y as a v, would be uv, product rule. U prime is 9 times v plus the y is y prime times 9x, 9xy prime. So this is what we have as a result of implicit differentiation. Now, what we are looking for is y prime. That's what we want. You see, I put underline. So that means we have to take these two terms together. Maybe on the left side is better. So I have already this term. I move this term to the left side, it becomes negative 9xy prime. And I keep 9y on the right side. Then I move this term to the right. So we minus 3x squared. Now if you look at it, they both have y prime in common. So you take the y prime out. It remains 3y squared. It remains minus 9x. And on the right side, same thing, you just write it down, whatever you have on the right side. Now, we got to get rid of these in order to get y prime. Therefore, y prime is nothing but this divided by this. So we divide both sides by 3y squared minus 9x. 3y squared minus 9x. These two will be cancelled. Therefore, what you have is called first derivative, which in fact is nothing but the slope function. When we say function, that means there is x and y is involved. You can see it. Now, if we want to find a certain slope, or a slope at a certain point, the point is 2, 4. Plug in 2, 4. So y prime at point what? At point 2, 4, which means x is 2, y is 4. Then that becomes, anywhere you see x, put 2, anywhere you see y, put 4. So it would be 9 times 4 minus 3 times 2 squared, and 3 times y squared would be 4 squared. And you have minus 9x. Minus 9x would be 9 times x is 2. That's it. If we do these calculations, which means that's a 4 times 3 is 12, and that's a 36, and 16 times 3, 48 minus 18. So you should be able to get the answer as the slope of this function. The answer becomes, I think, is 4 divided by 5. That's what they have. Yes, they have 4 divided by 5. 4/5. So this you could use your calculator. Simply just, use a calculator, multiplication and then exponent, and then multiply again, subtract, and then do the same for the bottom, and then divide. You will get that 4/5. This 4/5 is the slope. On the other hand, you're looking for this equation of a line. Equation of a line, if you have the slope, which is 4/5, and if you have the point, also 1 point of it, 2, 4, and the formula is this. That's called point-slope formula. Y minus y1 equals to little m times x minus x1. If you see, I put little because the little ones are given to you. M is given right now is 4/5. So this you have it. X1 and Y1 is given to you. X1 is equal to 2 and Y1 is equal to 4. All you have to just plug in. So minus 4 equals to M is 4/5 times X minus X1, and X1 is 2. That's it. This is the equation of a line which is tangent to the curve that they gave you. Therefore, this final answer comes from here. Actually, sometimes they just leave it like this, or sometimes they just solve it for y. You could write it any way you want to. So we can write it, the final answer, as after you multiply the distribution and then take -4 to the right, which is +4, and put all these together, you should be able to get it for 5 of x plus 12/5. That's it. This is called the equation of tangent line. Equation of tangent line. So this is what I wanted to tell you. Again, there is another example. Example is about the demand, and maybe we can discuss it later. But again, this is something I can leave it to you, and if it's not difficult, again, it's the same, similar, and so we can do a little bit maybe later, and I just leave the problem to you. See if you can do it. Yeah. So the demand function is for a certain commodity is given by this. P is equal to 500,000 and 2Q, Q3 plus 400Q plus 5,000. So there's a numerator and that's the denominator. And P and Q. Q is the quantity and P was the price of each item. This is example 4. And again, I just write the problem and I want you to think about it and do it. And in your spare time, it's like you are doing your problems online, your homework problems. So this is something like that. Think about it at least. Then I can discuss for you. So you know what is Q, what is P. Question is, can you find the derivative with respect to P of both sides? So derivative of this with respect to itself and this with respect to P. Some book, again, here they may assume that P is equal to X and Q is equal to Y, but you have to take the derivative. In the end, what you need to find is what is dQ divided by dP. How much is that? That's the question. It's like if Q is Y and P is X, what is dy over dx, which is Y prime? So this is what they're asking you. So I want you to look at it carefully with the discussion we had today. You know what is the explicit differentiation. So I want you again, take a look at carefully from the definition, from the formula, from the example 1 and example 2 in terms of the equation, finding equation of tangent line to a curve. And here is a relation between P and Q is given to you. Take the derivative of both sides with respect to P. It's like you take into it, if this is X and this is Y, take into it with respect to X. Derivative of this with respect to X would be 1. P with respect to P is 1. X with respect to X is 1. Then you got to take the derivative of these. That's a fraction, and you know how to take the derivative of fraction. We have a quotient rule, and you got to use the quotient rule. Here is U divided by V. So that's a U. This is V. And then the derivative becomes U prime times V minus V prime times U divided by V squared. It's called quotient rule. All right. So this is what I had in my mind to discuss it today. And again, I will see you again online. And good luck to you. I will see you next time.